Introduction to Automotive Diagnostics. Automotive diagnostics is the process of identifying and analyzing problems within a vehicle's systems using specialized tools and technology. As vehicles have become more advanced and computerized, diagnostics has evolved from a mechanic's instinct to a data-driven science. Modern cars are equipped with an onboard diagnostic system OBD, typically OBD-II for vehicles manufactured after 1996, which monitors and controls many components like the engine, transmission, exhaust, and emission systems. When the system detects a malfunction, it generates a Diagnostic Trouble Code DTC and often triggers a warning light, like the check engine light, on the dashboard. Automotive diagnostics involves more than just reading these codes. While a basic OBD-II scanner can pull the code, for example, PO for 20, catalyst system efficiency below threshold, the real skill lies in interpreting the data behind it. Technicians look at live sensor readings, freeze-frame data, and sometimes perform hands-on tests to figure out the root cause. One code might have multiple potential causes. A misfire code could mean anything from a bad spark plug to a faulty fuel injector or even a timing issue. There are several components and tools used in diagnostics. OBD-II scanners plug into the car's port and read codes. Multimeters and oscilloscopes used to check voltages, signals, and electrical continuity. Scan tools with advanced software provide live data, graphing, system tests, and manufacturer-specific codes. The value of diagnostics is huge. It allows problems to be detected early, prevents unnecessary part replacements, and ultimately saves time, money, and guesswork. It's also essential for emissions control, fuel efficiency, and overall vehicle safety. Whether done by a professional technician or a savvy dyer, automotive diagnostics is the foundation of smart vehicle maintenance in the modern era. It bridges the gap between vehicle symptoms and the actual source of the issue, making it an essential skill in today's automotive world. Scan tools with advanced software in automotive diagnostics. In today's automotive world, basic code readers just don't cut it anymore. Modern vehicles are complex, computerized systems that require scan tools with advanced software to accurately diagnose and service them. These tools go far beyond just reading trouble codes. They interact directly with your vehicle's ECU electronic control unit and provide real-time, in-depth diagnostics across multiple systems. What are advanced scan tools? Advanced scan tools are diagnostic devices, often tablet-style or laptop integrated, that connect to your vehicle's onboard systems via the OBD-II port. Equipped with manufacturer-specific software and data libraries, these tools can read and clear generic and manufacturer-specific DTCs, display live data from sensors in real time, perform bidirectional control like activating fuel pumps, turning on fans, etc., run actuation tests and system calibrations, program or relearn components like throttle bodies, TPMS sensors, keys, etc., reset service lights and perform maintenance functions, oil resets, battery registration, etc. Why are they important? Well, a basic scanner might tell you that your car has a misfire, for example P0301 cylinder 1 misfire. An advanced scan tool can go deeper and show you live cylinder balance, ignition timing, injector pulse width, and more, helping pinpoint the real cause. These tools are especially useful for diagnosing ABS, airbag SRS, transmission, HVAC, and hybrid electric drive systems, coding and programming modules in newer vehicles, supporting multiple brands through one device universal scan tools. Examples of advanced scan tools and brands. Automaxis series, popular with pros for its full system capabilities and fast interface. LaunchX for 31, affordable and powerful with wide vehicle coverage. Snap-on Solus, Veris, or Modus, professional-grade tools with top-level features. OEM-specific tools like TechStream, Toyota, INPA BMW, VCDS Volkswagen, or Forescan Ford for deep-level access on one brand. Key features to look for. Feature, benefit. Bidirectional control, activate systems like fans or EGR valves for testing. ECU reprogramming, coding, adapt or replace components common in newer cars. Live data graphing, visualize sensor trends over time. Freeze frame data, see the conditions when a fault occurred. Coverage for all systems, not just engine, but ABS, airbag, transmission, etc. Final thoughts. With the rise of complex electronics, advanced scan tools with smart software are no longer optional, they're essential. They allow for faster, smarter repairs and give you full control over your vehicle's diagnostics and service routines. If you're serious about diagnosing and fixing modern cars the right way, investing in one of these tools is a game changer. Multimeters and oscilloscopes in automotive diagnostics. When it comes to diagnosing electrical and electronic issues in modern vehicles, multimeters and oscilloscopes are two of the most powerful tools in a technician's toolkit. While both are used to measure electrical properties, they serve different purposes and provide very different types of information. Multimeters. The Diagnostic Swiss Army knife. A multimeter is a handheld device used to measure voltage VE, both AC and DC, current, resistance omega, continuity to check if a circuit is complete. Some advanced models even test diodes, temperature, and frequency. In automotive diagnostics, multimeters are essential for testing battery voltage and alternator output, checking ground circuits, verifying sensor resistance like coolant temperature sensors, ensuring continuity in wiring and connectors. Why it's useful: it's quick, easy to use, and perfect for basic electrical checks. If a car won't start or a sensor isn't responding, a multimeter is your first go-to tool. Oscilloscopes, seeing electrical signals in real time. An oscilloscope, often just called a scope, takes diagnostics to the next level. It allows you to visualize electrical signals over time as waveforms. This is especially useful for spotting sensor signal behavior like crankshaft or camshaft sensors, injector and ignition coil patterns, intermittent faults or voltage drops, noisy or failing ground signals. Unlike a multimeter, which gives you a single value, an oscilloscope shows you how a signal changes in real time. This makes it invaluable for diagnosing modern, fast-switching components. Why it's useful: oscilloscopes help detect issues that a multimeter might miss, especially in complex systems with variable signals or timing issues. They're crucial for diagnosing misfires, CAN bus problems, and intermittent faults. What are OBD-II scanners? OBD-II scanners, onboard diagnostics, second generation, are essential tools used to read diagnostic information from a vehicle's computer system. They allow mechanics and car owners to access trouble codes and data related to the performance of the engine, emissions system, and various sensors, helping diagnose issues quickly and efficiently. What do? An OBD-II scanner connects to your car's OBD-II port, usually located under the dashboard near the steering wheel. Once connected, it communicates with the car's ECU engine control unit to read Diagnostic Trouble Codes (DTCs), clear codes, and turn off the check engine light. Monitor real-time sensor data like oxygen sensors, fuel trims, RPMs. Access vehicle information like VIN, calibration ID, etc. Perform system tests on some models like EVAP or emissions readiness. Types of OBD-II scanners: basic code readers. Affordable and simple to use. Read and erase codes, best for everyday car owners. DIYBLUETOOTH, Wi-Fi scanners, pair with a smartphone or tablet using apps like Torque, OBD-II, or Car Scanner. Show live data and allow some customization. Ideal for tech-savvy drivers or hobbyists, professional scan tools. More advanced with manufacturer-specific diagnostics. Can reset service lights, perform active tests, and program modules. Used by technicians and auto shops. Why are they important? The biggest reason to use an OBD-II scanner is efficiency. Instead of guessing what's wrong with your car when a warning light comes on, the scanner tells you exactly where to start looking. This saves time, reduces unnecessary repairs, and gives drivers more control over vehicle health. Plus, many countries require emissions compliance, and an OBD-II scanner can verify if your car is ready to pass inspection. Fun fact: the OBD-II standard became mandatory in 1996 for all vehicles sold in the United States. Today, it's used globally across nearly all gasoline and diesel vehicles.